Hey, feeling good, like I should. When in circle, walk around the neighborhood. Feeling blessed.
Alrighty, we're going to jump into lesson 10.1.2, where we're now going to deal with cylinders, finding the volume and surface area of a cylinder. And it's important for us to go back and take a look at the work that we've done with prisms for us to understand how the formula works for cylinders. So let's define cylinders and prisms. I guess we can put them together so you understand how they're similar to each other. A cylinder, which, like a can, is the most common type of cylinder. A metal pipe is generally in the form of a cylinder. Cylinders are solid figures that have two parallel circular bases. So you got the base on the top and the base on the bottom. And these circular bases, which are congruent to each other and parallel to each other, are separated by this lateral face that wraps around the cylinder. And that, if you ever take a label and peel it off of a soup can, you'll notice that that is the shape of a rectangle. So this lateral face that wraps around the cylinder is actually a rectangle, which is connecting the two circular bases, one on the top, one on the bottom. How does that compare to a prism? Well, the fact that you've got two parallel bases separated by rectangular faces, that's the definition of a prism. So a prism is a solid figure that has two congruent bases that are parallel to each other, just like with the cylinder. But in the case of the cylinder, they're circle bases. In the case of the prism, they're any type of polygon. And these, I might have said it already, but they're separated by the rectangular faces, the lateral faces that wrap around the prism. So this would be a base on the top. This is a base on the bottom. And one thing, this is called a rectangular prism because all prisms are named for their bases. So in the case of a cylinder, the base is the circle. In the case of a rectangular prism, it's not so easy to determine what the base is because every single face on this prism is a rectangle. So which one is the base? There's a very simple answer for it. Whichever one you want to be the base. If you want to have this side right here be the base, it can be the base. You can have the top be the base, in which case the bottom would be its congruent parallel base. You could have the left and the right be the bases, or the front and the back be the bases. For the prisms that are rectangular prisms, it really doesn't make any difference which rectangular face is the base. But when you get into any other type of a prism, like this triangular prism, the odd shape, in fact, I'm going to write this down. The odd shape, and by odd shape, I mean the one shape that is not a rectangle on the prism. Oops, I shouldn't say gives. Let's just say is the base. Okay, so there's the odd shape. It's not a rectangle. It'll have a congruent parallel base on the opposite side of it. And there will be rectangles connecting those. So this particular prism has a total of 3 rectangular faces, the left back, the right back, and this front rectangle. And then it'll have 2 bases that are triangles. So this particular prism has a total of 5 faces, 2 of which are the bases. The rectangular prism has a total of 6 faces. All of them are rectangles, and you just decide which 2 are going to be the bases. All right, so that pretty much covers prisms. When we get into the formula, there's a universal formula for finding the volume of prisms. All of the formula is going to work for every single one of these. It'll work for the cylinder. It'll work for any prism, whether it's rectangular, triangular, pentagonal, octagonal, any type of a prism. You're going to have the same basic formula for finding volume, and we'll get to that in a little bit. All right, in order to be successful with today's lesson and with finding surface area and volume of cylinders, we've got to make sure we understand how to work with circles. This was something we did last year in 7th grade, being able to find the area of a circle by multiplying pi times the circle's diameter. and being able to find the circumference of the circle by multiplying pi times the diameter. Did I say the diameter there? I'm making lots of mistakes today. Hold on for a second. Let me get back here. Yeah, no, pi times the radius squared. That's the formula for any area of any circle. So if I were to take these two circles, one of them gives us the diameter, the other one gives us the radius, but technically each of them, we know what the diameter and radius is of each one, because the diameter is that measure that goes all the way across the circle going through the center point, and the radius starts at the center point and goes to the end of the circle. The radius is always 1/2 of whatever the diameter is. So this circle with a diameter of 14 centimeters will have a radius of 7 centimeters. This circle with a radius of 4 inches will have a diameter of 8 inches. And so if you're trying to find the area, you need to convert the diameter to a radius. If you need to find the circumference, you need to change the radius to a diameter by multiplying it times 2. And then one last little deal here. Pi, the universal rounded off version of pi is 3.14, but your scientific calculators actually have a pi button, which will give you the most accurate measure. So this is the button I'm going to be using for most of these problems, just because whenever you round it off, you're going to get an answer that's a little bit lower than what the true measurement is. So if we could use the true pi by pressing this button here, we're going to get as an exact answer as we possibly can. So go ahead and copy these down. Pause the video. I've already done the work here, so I'll review these boxes to see if you've got the same answer as me. So go ahead and pause. Come back when you're ready. All right, I'm assuming you've done all the work and you did a fantastic job of showing your work. Let's start with the area of this particular circle. Area times the radius squared is going to give us, pi times the radius squared is going to give us the area. And so 7 squared is 49. So 49 pi, put that into your calculator. 49 times pi, what do you get? I'm going to round that off to the nearest tenth. And so that ends up being 153.9 square centimeters. How about the circumference? Well, for circumference, we multiply pi times the diameter, and the diameter is 14. So whatever 14 times pi is, 14 times pi, 43, I think I'm going to round that up to 44. 44 centimeters for the distance around that circle. Now for this circle, once again, we've got pi times the radius squared, so it's going to be 16 times pi. And what is 16 times pi? I won't bother with the calculator now. It ends up being pretty close to 50.3 inches squared. And then for the circumference, we're going to double the radius here because we need the diameter for this formula. So if the radius is 4, then the diameter is 8. So we're going to multiply 8 times pi, and we get 25.1 inches. Okay, so a couple things to be aware of here. When you're finding the area, come on, highlighter. Any day now. Okay, there we go. When you are finding the area, you're finding the number of square units. So make sure that your unit of measurement is in square units. How many total square centimeters fit inside there? 153.9, almost 154. We need to denote those as square centimeters, whereas the circumference is a linear measure, so that's just going to be linear centimeters, so there's no exponent. Same thing here. Got to make sure that you write your areas with square units and your linear measurements, your straight line measures, as inches to the first power. All right, now this is quite an involved activity in which we would have been probably spending a couple of days in class working on it, where you get a piece of paper and you get to fold the piece of paper, and it's great hands-on activity, but we really don't need to do that. But this is going to be a bit involved. This might take a little time. We're already 9, almost 10 minutes into the video, and we're barely even getting started. So this is going to be a longer video, and I'm sorry for that. But it's a good video for us to see a practical application of surface area and volume of prisms and cylinders. So take this case of a gym bag. We're going to compare, I'm going to give you the paraphrased version of all of this. We're going to take some cloth, and it's a rectangular piece of cloth, and we're going to fold it over and have it be the four sides of this gym bag, and then we're going to have to fill in a little bit of extra cloth on the ends to enclose this gym bag. But our task is to find the measurements based on this basic piece of cloth that's 40 by 52 inches that's going to wrap around it. Is it canvas? Did they say it was canvas? I don't know what it is, but who cares? But we need to see what is the surface area and volume of this gym bag that's in the form of a rectangular prism, and this gym bag in the form of a cylindrical sort of bag. So that's what our task is going to be. We're going to break down each one of them, and we're going to decide, we're going to see which one will have the greater volume and how do their surface areas compare. Okay, so let's just get into it. Oh no, we're not going to get into it yet. This is one more thing of review that we haven't done in a long time. So we went in the direction of having either a radius or a diameter to find the area and the circumference. Well, here, there might be a situation here. In fact, the fact that I put it in here, so there probably is a situation where you know the circumference of a circle, but you've got to figure out what the radius is so that you can find the area of the circle. Okay, so draw yourself a circle. Identify that circle as having a circumference of 78.54 inches. And let's see if we can work our way to figure out what the radius of this particular circle is. So remember that the formula says to take pi times the diameter to give us the circumference. And since we know the circumference is 78.54, we're going to write it in here. In which case, if I divide both sides by pi, then we're able to isolate our diameter, and we just figure out what is 78.54 divided by pi. Now, in this situation, I think I used the rounded off version for pi. 78.54, if we divide it by pi, it's right around 3. No, that's pi itself. It's right around 20. Oh, yeah, that's 25. So I guess it doesn't really matter whether we use 3.14 or if we actually use the pi button. We're going to get a diameter of 25 inches. Well, we don't want to find the diameter. We're trying to find the radius because we need the radius to find the area. So how do you find the radius if you know the diameter? Well, the radius is exactly 1/2 the diameter. So half the diameter is the radius, and half of 25 is 12.5. So that means that this particular circle, when we started with the circumference, we could figure out what the radius is. It's going to be 12.5 inches. And now if we need to find the area for this circle, then we just square this number and multiply it times pi, and that'll give us the area. All right, now that we're done with that, our task is to find the surface area and the volume of each gym bag, the rectangular prism and the cylindrical gym bag, okay? So let's start with this. Here, this was the measurement. Remember, the bag, everything going around the bag was this rectangular face. So our first task, I would recommend you try and draw a little bit of a sketch of this. That's what they say. Sketch your prism, and then let's answer these questions. Go ahead and pause if you want to take the time to write this into your journal so you've got these measurements. And while you're paused, might be a good idea for you to write down this net, because we're going to have to find the surface area for part B. Although I'm already giving you some information, so let's not go down there yet. Oh well, you see it anyway. So what is the perimeter of this square base? Remember, it's going for 40 inches in this direction, which represents this part of our rectangular cloth that's going to be wrapped around. So that means that the perimeter of this square here has to be this length, the height of this rectangle. So the perimeter of the square base is going to be 52 inches. So then what would be the dimensions of each side? Well, each side length of that square is going to have to be 13 inches, since we're going to have 4 sides And this total going all the way around is 52. So 52 divided by 4 is 13. That's why we've got the 13s written in here. So take some time, write down this net, and this represents the 4 sides of the bag, the rectangular prism, and then the one end on one side and the one end on the other. I guess these two, for this particular prism, would be considered the bases, or you could consider them the bases. It is a rectangular prism, so it really doesn't matter too much. Okay, so let's go ahead and figure out what the surface area of the prism is by finding out the areas of each one of these faces. Go ahead and pause. I'm going to write those in a second. I'll pause them as well. And when I come back, you come back, you'll see those individual areas. All right, so if every one of these longer rectangles is 13 by 40, that means that 13 times 40 is 520. Each one of these faces is 520 square inches. And these squares, the bases, are each 13 by 13, so they're 169. So you add them, put them all together, and you get a total surface area of this gym bag of 2,418 square inches. So now, for the volume, how are we going to figure out the volume? Well, we go back to that previous lesson that we were talking about where we were finding out the area of the base and then taking one layer. Remember that that L-shaped cake? If the base area is 169 square inches, then if you take 1 inch cubes for that first layer, that's going to be 169 cubic inches. So there was this formula that we learned last year that said that the volume of any prism is going to be what you get when you take the area of the base, so I write that with a capital B, and multiply that times the height of the prism. Now, I know you don't think this is a height because it's going from left to right, but if you were to tip this gym bag up on end so it was actually sitting on its base, then the 40 inches would represent its height. So we're going to take 169 square inches, and then we're going to multiply that times the 40 inches of height. So every layer is 169 cubic inches, and you've got 40 layers. So what is 169 times 40? Go ahead and do that calculation. And what did you get? That's what I got, 6,760 cubic inches. So that is the total amount of space that this gym bag can hold, the total number of cubic inches that would fit inside this gym bag. Okay, so now let's move on to the cylindrical shaped bag. Do your best to sketch this picture. Once again, you're using the same cloth. So the 40 inches is going to be like the height of this cylinder where the circles are the bases, right? And so that means that as you are figuring out what the circumference of this base is, you've already got that information because this cloth is being wrapped around. So in answer to this question, find the area of the lateral face. If you do not have enough information to find the area, list the measurements. Oh, okay, we're not quite to the circular base yet. What is the area of this lateral face that would be wrapping around? Well, how do you find that? 52 times 40, how much is that? That's going to give you the area of this section right here that's wrapping around. So I'm going to go ahead and write that in down here. That 52 by 40 is 2,080 square inches. Okay? So now Melissa's looking at the base of the cylinder and realizes that the only measurement she knows is the circumference. She knows the distance around. She thinks she can use the circumference to find other measurements. What is the circumference of this circle? Well, remember, this is the piece of cloth that's wrapping around, so the circumference must be the 52 inches. And what are the other lengths that she could find if she knows the circumference? Go back to what we did on that previous page. You could find both the radius and the diameter if you know the circumference. So that's what I would like for you to do next. You know what the circumference is. Go ahead and figure out what the diameter is for this particular circle by taking the circumference and dividing it by pi. Go ahead and pause and then come back when you're ready. Okay, we're assuming you did all that. You've come back and you're ready and you know what the diameter of this circle is. So the diameter is 16.6 inches. So the radius has to be half that. So the radius is going to be 8.3 inches. So each one of these circles has a radius of 8.3 inches. And we're going to use that now to find the area of each one of these circles. So I'm going to pause. You go ahead and pause. Figure out what the area of one of these circles is, and then double it because you've got two circular bases. And we have to find the area for the total. All right, let's see how you did. So we're going to take pi times the radius squared, and since the radius is 8.3 of each one of those circles, we'll square that to get 68.89. So that's the radius squared. Multiply that times pi, and my calculator said that was 216.4 square inches. So that means that each one of these is 216.4 inches. So I doubled that, and after doubling it, we got a total of 432.8 square inches. So to find the total surface area of this entire gym bag, we have to add the rectangular lateral faces area plus the area of the two circles. So 2080 plus 432.8 gives us a total surface area for this gym bag compared is 2,512.8 inches. All right, so how did that compare to the other gym bag? The other gym bag had a surface area that was 2,418. So it's going to require a little bit more area. While the rectangular faces, the lateral face, is the same area for both, the fact that we had a circle for our bases on the cylindrical bag means a slightly higher total surface area for the gym bag that's the shape of a cylinder. All right, now let's get to the volume. How do we find the volume of this cylinder? Well, actually, let me come back up here. We can use this because we're going to do the exact same process that we did when we found the area, when we found the volume of the other gym bag. We're going to use the same formula. Volume is equal to base area times the height. And the base area for this particular prism, this circle, is 216.4 square inches, and the height, which is the distance between the two circular bases, was this 40 inches, right? That's the distance between. So remember, if we created one layer of cubes, that would be 216.4 cubic units, and then we have a total of 40 layers, so we multiply that times 40, and we will have our total volume. So go ahead, use your calculator, figure out what the volume is. Well, I guess we don't really need to pause it. Let me just go ahead and do this. I'm going to take that number right there and then multiply it times 40. And it's like 8,656. Could that possibly be right? I feel like I might have made a mistake. That is much bigger than the other one. Let's try this again. 216.4, which is the area of the base, the circular base, times the height, which is 40. And you stop. What is going on here? 216.4 times 40 equals 8,656. 8,600. I'm going to make that a 656, and my OCD won't allow that. Let's just go ahead and rewrite this so it looks nice. 656. That's the volume of this gym bag, and that is in cubic inches. All right. What was the volume of the other bag? The other bag was 6,000. This is almost 2,000 more cubic units, cubic inches, just by putting our gym bag in the shape of a cylinder as compared to a rectangular prism. Almost the same amount of fabric was used for both of them. They were only a difference of maybe 100 or so square inches, but a difference of almost 2,000 cubic inches. So I guess the lesson to be learned is this: if you're going to the sporting goods store and you're looking for a gym bag and you want the gym bag that's going to hold the greatest amount of gym clothes and towels and anything else, choose the one that's in the shape of a cylinder. The cylinders hold more volume than the rectangular prisms. Who knew? And I think that's kind of where we're going with this question and that question. So we're going to skip over those. And now I'm going to pause this, and I want you to do this on your own. Find the surface area and the volume of this particular cylinder. Pause. And when we come back, I'll have the answers. All right, we're almost there. Let's see how you did. First of all, I'm going to share this with you. This is not an easy formula to remember for the surface area of cylinders. I never recommend students memorize these formulas other than the basics. Memorize the basics for finding the area of circles, rectangles, and triangles, and for finding the circumference and perimeter of those shapes. For the surface area, this is a formula that works, but it's basically just saying you've got two circular bases. So find the area of the two circular bases and double it. One area for the top and one for the bottom. And then the lateral rectangular face is the circumference of the circle, which is pi times the diameter, times the height of your cylinder. So if you can remember this formula, you really don't need to use it too much. Just find the various areas and then add them all together. So first of all, the circumference of this circle is 31.4 centimeters. Because we're going to take pi times diameter, and the diameter is 10, so pi times 10 is going to round off to 31.4. The area of the circle is pi times the radius squared. If the radius is 5, then the radius squared will be 25, and 25 times 5 rounds off to 78.5. So when we're finding the areas out, you've got one lateral face and two circular bases. So we're going to take the lateral face, which is a rectangle 12 by 31.4, and then the two circular bases are each going to be 78.5. So you add those together for a total surface area for this cylinder is 533 8/10 centimeters squared. Surface area for cylinders is actually pretty complicated. It's involved. The volume is much, much easier, which I'm hoping you figured out. The volume is just going to be the area of the base times the height. And we've already figured out the area of the base because we did the work over here. So we're going to take 78.5 times 12. And once you've got that, you've got your volume. Simple as that, 942 cubic centimeters. So this just takes time and it takes practice, and use your calculator, draw pictures of these shapes, write down the formulas. Don't try and do too much in your head. If you try and do too much in your head, you're going to lose track of everything and it gets overwhelming. So do your best, record your work, and let your calculators help you with this process. All right? Okay, so there'll be a check for understanding tomorrow, and you are going to get a test on this. So I guarantee you, you're going to see rectangular prisms, triangular prisms, cylinders. And we haven't even gotten into cones and pyramids yet. So make sure you understand this before next week when we get into our cones and pyramids. All right, take care. Good luck on the homework.
Hey, feeling good, like I should. When in dark, walk